hopefully you're here for this particular group, wireless communication, sensing, and networking group, right? So that's the group I lead. So briefly, let me tell you, our group really starts from wireless and branches out to various other systems, and we have huge impactful applications developed for different systems, right? And I'll cover some of them, right? So our group has extensive application to autonomous systems, sensing systems, AR, VR, IoT systems, right, and healthcare and many other applications, right. So just to cover, right, and then just to summarize the vision for our group, right. So really, if you think about it, right, there are a variety of applications out there, right? Okay, starting from self-driving cars, robot, AR, VR, right? What has changed in the past decade or so is really instead of providing wireless is not used for providing connectivity to them, right? That's like kind of a given thing now. It's shifting from a trend where instead of providing connectivity, you're trying to go to provide control and sensing for these systems, right? So this is what I called as all things, right? Okay. And so essentially, if you think about it, right, all interaction between objects, machines, and humans, right, is driven by wireless connectivity. And you need a network to accommodate these, right, and control and sense around them. Okay. So really that's what we end up doing in this group. Okay. And I can take one particular some examples, right? And even IoT sensor, I don't know why the IoT sensor was waiting behind, right? Let me just go through some points, right? So what is unique about my group, right? So first, I think we are very much focused in starting from theory, right, translating to actual applications, right? And I'll explain you some of the applications which we have built in my group, right? Okay, and they have really transform existing robotic systems, right? Autonomous systems, right? Healthcare, AR, VR, and how we can think of them right today, and how they can be actually with what we do here, right? So the core thing is that we actually try to find out what is the fundamental problem and try to attack that fundamental problem, right? And this actually should also work on real systems, right? Not just remain in theory, right? The one other thing today morning, I was just discussing with some of my students, right? And they said, what should I articulate, right? And they said that what we feel great is that we have freedom to pursue our own ideas, right? And publish them as we desire, right? So that I thought maybe it's happening as a natural course of how we are growing as a group, but it was a very unique perspective from some of the students which I was discussing. I want to bring it up, right? And so the other thing is that what happened is that because you are trying to do from theory to practice, right? We end up having a very diverse group of people who have experiences on hardware, software, building theory, simulation, modeling. So we really are bringing a lot of diverse people, and all of them are put together to build an entire real system, right? So building a real systems is a lot of hard work, and I think anyone who has done has an appreciation for the same, right? And therefore it also requires a community, right? So we really are a community, and I'll go towards my end of my talk, right, and explain how we see it as a community and what is life at WSNG, right? So let me start with a few projects, right? First problem statement, which actually I worked on, right, is so it's not generally possible for radios to transmit and receive at the same time on the same frequency, right? And really the problem is that if you're transmitting on the same time on the same frequency, right, your transmitted signal acts as a huge interference, right? For example, let's say if radio 1 here is trying to talk to radio 2 at the same time, radio 2 transmit to radio 1 on the same frequency on the same time. The problem is this red signal will act as a very strong interference and it cannot receive this green signal, right? It's like you and me shouting at the top of our lung and trying to hear each other's weak whisper. We cannot, and the same goes for the radios, okay? And this self-interference, in fact, is 100 billion times stronger than the actual received signal, right? So imagine you have to cancel this 100 billion times strong signal, right? Even ADCs don't exist with this kind of resolution today. So in my research, right, I have shown how you can solve this open problem, right? This is a decade-long open problem. We built analog, digital, and interference cancellations at multiple hybrid stages, right? And we showed that commercial off-the-shelf chip, right, transceiver, $2 transceiver, right, can be enabled to make full duplex with some analog cancellation in the front here, right? And This analog cancellation eliminates most of the interference, right? And then the rest of the interference remaining was limited in the digital ASIC design here, right? And it achieves the doubling of spectral efficiency here, okay? And this, I think, work I actually even translated into practice, right? I started a company around this, and really we built a first product. We raised some amount of millions of dollars, right? $55 million to be precise here, right? And then this technology has been actually successfully demonstrated with Prime Telecoms, right? Deutsche Telekom, Telecom Italia Mobile. You might be wondering why European telecoms. Fact of the matter is that US telecoms are a little bit slow, right, in adopting new technologies, right? So it's better if you have something cool, go to South Korean telecoms or European telecoms. They are very, very adaptive and really leading a lot of the 5G as well, right? On that respect, right, um, there is another project which is done by recent early student Manideep Tunna. And what he built is a smart surface, right? And this was actually featured in a lot of different news articles, right? And this is what his work was really doing, building a smart surface which can essentially build a connectivity for existing Wi-Fi devices, right? So imagine some areas in your house do not have any connectivity, right? And what it does is that you just stick a this smart surface on your wall, and it suddenly you'll have connectivity everywhere, right? And not only that, in the areas where you already had connectivity, you'll get twice the throughput gain, right? All with just deploying this passive smart surface, right? It has no power, just a whole lot of antennas. All of these are optimized, and it's extremely low power. You can just hang it behind a painting, right? You won't even see it, right? And it seamlessly integrates with Wi-Fi and costs less than $5, right? You can imagine even this would have a huge impact. And already this is why it was captured with extensive news article, right? In retrospect, right? Just to give you how this decomposition from this idea to actual simulation models we used to understand how it will well perform, right? Okay, and we've identified what is the right way of architecting and designing these values, and how do you kind of go about optimizing them, right? We framed it as an optimization problem, right? And then finally we made a prototype out of it. Okay, we built an array which has essentially this phased 16 antennas, right? And we had 3 of those tiles in the painting we showed, right? And this is the configuration design for hardware, right? And we actually showed it works in a real system with a commercial Wi-Fi access points. Okay, so sorry, I have this picture, right? 3 of those, right? These wires are just some digital control to the smart surface, right? And that's it, right? Okay, I like this picture though a lot. Okay, going forward, right? That is another recent work, right? Okay, one of the biggest problem in the world of autonomous systems is that lidars and cameras do not work in bad weather, right? If you have rain, fog, or snow, right, none of these lidar and camera work, right? Because anything you transmit does not reflect back and get you the right point or reflections, right? And therefore you can't see the actual scene, and you therefore cannot decide and have these self-driving cars work, right? However, radars, right, okay, are all weather or can be all weather persistent, right? Okay, or they do not get impacted significantly by weather. Okay, so in this particular case, right, we were like, okay, can we use these radars, right, to do essentially what lidars and cameras do, right? Lidars and camera create really, really detailed information about dynamic objects like cars and other things, right? But radars on the other hand just gives you few points of reflection, right? They do not give you these dense points. So in this work, right, Kshitij actually, this is work from Kshitij, right? He built a deep learning powered solution with multiple radars combining signal processing and deep learning. He kind of showed that there is a way to even do bounding boxes, right? And here is his particular model which does this, right? And even under fog and everything else, it can see and map and point this box accurately on that car. It may not look that accurate, but it is very accurate. Okay, so this was covered under I don't know, various news articles again, right? Okay, and we have a lot of interest from industry right now on trying to commercialize this technology as well, right? So to sum it up, right, I can give you about more projects, right? But really we are covering these many areas, right? We have signal processing, deep learning, embedded systems, millimeter wave communication, sensing, and so on and so forth, right? So these are like really the skill set which we have developed within the group, right? And there are many projects which are going on, right? Covering variety of applications, right? From passive sensing to wireless communications and so on and so forth, right? So I'm not going to bore about the details of these projects, right? I'm going to now cover a little bit of what it means to be at UC San Diego on UCS, WCSNG, right? This is our lab. So this is, I don't know, PhD comics, if you guys have seen, right? It goes from literature survey. You see that you are so smart, right? You can do so many cool things. And then your simulation still says the same thing, right? You're cool, right? And suddenly you start doing experiments, right? And you realize, oh no, right? And then you essentially end up going this loop. So this is really what the life looks like at WCSNG. But we do it in a fun way, right? We have graduation parties. This is my extended group. This is 2019, right? And we have people from all nationality. We are doing a graduation celebration. This was 2020 with COVID, right? And still the same thing, 23 people still at least I can see here, right? This was maybe towards the end, right? We were doing virtual games, right? And a whole lot of people getting together who have a short clicks. Not that we are promoting people to stay in same places, right? This is celebrations pre-COVID, right? We have festivals, right? This was Diwali. We have also New Year just celebrated this year, this week, right? And this is Chinese New Year, by the way, this week, right? And then we have birthdays and celebration, right? Extended group. And I'm always here, right? If you don't find me, it's hard to find me. I'm this here with the extended group again. And we also go to CES sometimes, right? In Las Vegas, and we have these tour parties, right? And this year we didn't have Diwali celebration. And as usual, I think Agrim feels so confident that he can post this, right? Where's the party? And this is me, he commenting me on Slack, right? So the point I want to make is that really we do have a lot of freedom, right? We do pursue our own ideas. It goes for me as well, right? Not just every other member in the group, right? And this is what we happened. We had an outdoor party, right? As such, um, I will let you take some questions at this point. I think I've already taken 12 or 14 minutes. Sorry for that. You have 5 more minutes and you can ask questions. Go ahead. Thoughts, questions?
Can I ask a question?
Go ahead, Tyler.
So you were talking about how you're doing radar instead of like lidar
Hmm.
to get better imaging. Do you
Hmm.
guys ever? Because we talked at the very beginning, not in this group, but how groups kind of work together. So do you ever
Right.
work with like, computational imaging labs or whatnot?
So yes, in this particular case, we work with actually what was more suitable was we worked with Toyota as well, right? And as an industry collaborator, right? So we do end up working with recent collaboration. We have a different collaboration with video image processing lab where they are doing camera based bounding boxes and 3D bonding boxes. I think we are working with them right now and trying to fuse camera and radar, right? I think that actually makes a lot more sense because lidars are super expensive, right? And if you can deploy a technology which only uses camera and radar, that could really work well, right? And camera gives you light, right? As in light based sensing, and radar gives you like wireless, which is working at a different, fundamentally different frequency, and therefore fusing them together makes a lot of sense, right? And that's what I think right now we are pursuing as a collaboration. So yes, we do collaborate a lot with the leading computer vision as well, and I think my group also works on some of the computer vision problems. We have in another collaboration, just to give you Tyler example, right? We started with this concept in network coding where we were doing code word translation instead of network coding has been not that useful so far, right? And what we figured out is a new code word translation mechanism, and we showed in prototypes how we can build a backscatter connectivity, right? So imagine I have a Wi-Fi device, right? Okay. What if I could backscatter and communicate my data back to the Wi-Fi access points, right? And that way, if I backscatter, right, as a tag, I need very low power, right? And I still can talk to Wi-Fi, okay? So it gives you extremely low power Wi-Fi connectivity, right? Super useful for IoT devices. Now, this was a very interesting concept, right? We were doing backscattering and we figured out a new code word translation. It's a kind of a networking coding inspired protocol or a technique And we recently have built an entire RF integrated circuit out of it. Okay. So it went from this theory concept, we built prototypes, and then in recent time, we actually built an integrated circuit. So we have like in last 2, 3 years, published a couple of integrated circuit papers on top of this concept and also systems work, right? If you want, I can give you some pointer, right? And you can just go check out the webpage wcsng.ucsd.edu, right? I think easiest webpage, right? And you can go look at publications and you'll see a whole lot of cool things going on that end. Great question, Tyler. I think we do have very good cross-cutting collaborations, right? This is a collaboration with the circuits folks, right? There is another collaboration we have within CSC department. We are working on security systems, right? And trying to identify vulnerabilities in wireless communication systems, right? We do have a lot of industry collaboration when it's desired. A lot of our hardware, when we need to acquire, it comes from a lot of third-party companies, right? Which are really good at those hardware, but we do not want to invest our time and resources in building those hardware, right? So that makes a lot of sense, right? Then there is another collaboration I have with uh, Pam Kosman, Professor Pamela Kosman. I don't know if you have heard of her, but really where we are trying to understand the one slide I had on how virtual reality and how wireless virtual reality systems can be built and deployed so that your videos is delivered in a very high quality fashion even when the wireless link goes up and down, right? Okay, so that's kind of one theme, and we are doing a cross cutting work where we are changing video compression algorithm as well so that it meets better the target goal for the VR virtual reality as well. So that's another theme of collaboration going on. So yeah, I think very collaborative group, right? In the sense that if you want to explore, go work with, I don't know, recently one student wants to go work with Aditya. Actually, he's here with me, right? Aditya Arun. He wanted to work with Nikolai on something like robotics, and he wanted to combine GT Slam with the wireless localization, right? And build SLAM algorithms with wireless camera, right? Imagine right now we have cameras which do SLAM on robots, right? What if you could use your Wi-Fi and wireless radios, right? Okay, to kind of fuse them and make them look like camera, right? And do the same GT Slam algorithms, right? Which you do with cameras, right? And he's working actually on that right now. I have a question on chat. Um, in pointillism, that's the work which I pointed. Why can't we use more radars instead of two to get accurate sensing slash estimation? So actually on that end, we did try like even 4 or 5 radars. And what we learned is that really aperture is what matters, right? And right now what we are doing is really, we are thinking of radar as an ecosystem for communication, right? What if multiple cars radars also talk to each other and share their data with each other, right? How can they fuse it and how can they make it really well work well, right? So yes, we have tried with 4 radars on the same car, and now we are scaling it up to multiple cars and seeing how well they can work as well.